Okay, ji. Partial fractions. Now, what are partial fractions? Let's just rewind our concepts from our O-level basis. In O-levels, what you used to do was you used to have two different fractions, like 2 upon x plus 2, 4 upon x plus 3. And the examiner would always want you to write down as express this as single fraction. So what you used to do was you used to take LCM of the both expressions, which means x plus 2, and we used to have x plus 3. And what do we repeat? We used to do 2 multiplied by x plus 3, and 4 should be multiplied with what? X plus 2. Obviously, we can always have that LCM can be cross multiplied because of two LCMs together. So 2 being multiplied with x plus 3 and 4 being multiplied with what? X plus 2. And if we just open the bracket, what we used to have was 2x, 2 into 3 is 6, plus 4x plus 8, and x plus 2, x plus 3. And following on, 2x plus 4x becomes 6x, plus this should have been what? 14 upon x plus 2 and x plus 3. So now in partial fraction, what we need to have is we need to bring the same single fraction to the value of the different fractions given. That means we need to break the single fraction to multiple fractions with the value of what in the numerator that is given as 2 and 4. Because obviously you already know that denominator you will have x plus 2, x plus 3. But you need to find out the values that are in the numerator. So there is a certain step that you need to follow. First of all, that you need to understand that there are 4 cases of partial fractions. So we'll be doing the first case. That means linear expressions, or in other words, I can say linear roots. Linear roots. Now, let's take an example of the same question that we did. We did 6x plus 14, 6x plus 14, and this is as x plus 2 and x plus 3. What we can see is there are two expressions in the denominator. One is x plus 2, the other one is x plus 3. We can always break these into two different fractions. That means we can have a upon x plus 2 plus b upon x plus 3. Knowing the fact that these are linear roots, that means there is no power on any of the variable or over the brackets. Let's just solve this as they are, right? So we have 6x plus 14 upon x plus 2, and what do we have? X plus 3. And we take the LCM of the same brackets that we did, x plus 2, x plus 3. But here we'll write down as x plus 3 multiplied by a, whereas b will be multiplied with x plus 2. But here what do we see? We see that the denominators are same. So if the denominators are same, what we do is we cancel out the denominators, and the expression that you will be left with is 6x plus 14 is equal to a, x plus 3 plus b, x plus 2. When you are doing case 1 with linear roots, you need to understand that your roots will help you out to find out the value of a and b. Your roots here are, so roots are x plus 2 and x plus 3 as an expression. So what we can write down is that your roots can be written as this, since this is x plus 2, we can write x plus 2 is equal to 0. Your roots will be x plus 2 is equal to 0, whereas x plus 3 will be written as x plus 3 is equal to 0. So that means when x plus 2 is equal to 0, this can be x is equal to minus 2. Whereas x plus 3 is equal to 0 will be x is equal to minus 3. So when you know that the roots are given, so particularly for the values, we can write down the values of x as well. So that means considering that x is equal to minus 2 and x is equal to what? Minus 3. We can find out the values. As I said, that the values of x, the roots can help you out to find out the values in the numerator for a and b. So when your x is equal to minus 2, can we say that 6x is what? Minus 2, and the entire equation remains same. If we write down minus 2 here, so minus 2 plus 2 becomes what? 0. And anything multiplied by 0 will become 0. That means b gets eliminated. So that means minus 2 plus 2, b gets eliminated. But here minus 2 plus 3 will become what? 1. So what we can have is, we can always write down value considering the fact that this is 6 minus 2 plus 14, whereas a is equal to minus 2 plus 3. Obviously, if we put down minus 2 in the bracket of what? B, it will become what? 0. So knowing the fact that this is minus 12 plus what? 14 is equal to a, 1. So the value of a will become what? 2. So looking at the expression initially, if you see that a here was particularly 2. Now let's just find out value of b as well. We knew that x is minus 2. We knew that x is minus 2. Do we know that the other value is minus 3? So let's just write down when x is equal to what? Minus 3. So can we say 6 minus 3 plus 14? If we put down minus 3 in the bracket of what? In the bracket of a, minus 3 plus 3 will become what? 0. So since minus 3 plus 3 will become 0, you are left with what? Minus 3 plus 2 only. So knowing the fact that we have b is equal to what? Minus 3 plus 2 left. Because if we put down in the bracket of a, it will become what? 0. Can we have minus 18 plus 14 is equal to what? B is equal to minus 1. This should be minus 4 is equal to minus. So B value becomes what? 4. So now, since we already know that 6x was what? A value was what? B, A value was 2, whereas B value was 4. We can always write down the expression as the given form, which means we can substitute your 6x plus 14 upon x plus 2, x plus 3. We'll write down 2 here and we'll write down 4 here. And obviously this will be in the given form. This is case number 1 for the linear roots. Okay, let's just work out with other example, that is x upon x minus 1, x minus 2. We can always write down this thing as a upon x minus 1, where this would be plus b upon x minus 2. So if we just open the brackets, or we can just take down the LCM, x minus 1, x minus 2. This will be taken down LCM as well, x minus 1 and x minus 2. Remember this, that the denominator, the LCM will be same. So you don't have to worry about anything. Whatever the LCM is in the question, you're going to write down the LCM same here. So you don't need to worry about this thing. So A becomes x minus 2 plus b will be multiplied with what? X minus 1. Now knowing the fact that x minus 1 is there, so the first value would be when x is equal to 1. So considering that the x is equal to 1, your denominators will be cancelled out. So you are left with only, that is, x is equal to a, x minus 2 plus b, x minus 1. So if we just put down 1 in x, so a 1 minus 2. And if we put down 1 in the bracket of b, so 1 minus 1 becomes 0. Anything multiplied by 0 will become 0. So 1 is equal to a minus 1. A becomes what? Minus 1. Whereas when we know that the other value is x minus 2. So the value should be when x is equal to 2. So when x is equal to 2, what we can do is we can again use the same equation, that is x is equal to a, x minus 2 plus b, x minus 1. Let's say 2, a. 2 minus 2 becomes 0, whereas b, 2 minus 1. So this is cancelled out, 2 is equal to b, and obviously 1, b value will be what? 2. We can always write down, as I said earlier, that the given equation will be written down in the same way that is there in the question, x minus 1, x minus 2. Your a is minus 1, b is 2. So let's write down b first, b upon x minus 2 minus 1 upon x minus 1. Why did I do this? Because obviously if we show negative value, afterwards, since we have one positive value, the other one is negative. So always keep the negative value after the positive one. So this was another example of the linear root. Here's the other example. Let's just solve this through the given roots. So this would be a upon x minus 1, b upon x minus 2, and c upon x minus 3. Now, knowing that the LCM given is x minus 1, x minus 2, x minus 3, what we can do is x square minus x plus 1. We can always write down x minus 1, x minus 2, and x minus 3. As I said, the LCM for the working would remain same as the question, x minus 2, x minus 3. So what do we write with a? Since x1 is under a and x1 is in the LCM, so x minus 1, x minus 1 is cancelled. So you're left with what? X minus 2 and x minus 3. Whereas b, you have denominator x minus 2. So x minus 2, x minus 2 are cancelled. You're left with x minus 1 and x minus 3. And for c, you have denominator x minus 3. So x minus 3, x minus 3 are cancelled. You're left with what? X minus 1 and x minus 2. So now you know all the three roots are linear. So taking the values when x is equal to 1, when x is equal to 2, and when x is equal to 3, all we need to do is substitute the values and then find the value of a, b, and c. Let's take when x is equal to 1. So what we do is we substitute 1 square minus 1 plus 1 is already there. So we can always use a as 1 minus 2 and 1 minus 3. But if we substitute this in any other particular bracket, if we substitute 1, 1 minus 1 will be 0, so b is cancelled. If we substitute 1, 1 minus 1 is 0, so c is cancelled. So you are left with only a. So what we can do is we can write down the value as 1 is cancelled out, so you are left with 1, whereas a minus 1 and particularly minus 2. So minus 1 minus 2 is 2 and 2 will be divided on the other side. Then similarly, we already know this, that we have the other value as well, which is when x is equal to 2. So what we're going to do is 2 square minus 2 plus 1, and if we substitute 2 in the bracket of a, so 2 minus 2 will be 0, and if we substitute 2 in the bracket of c, so 2 minus 2, c will be cancelled. So you are left with only b, which will be written as B, 2 minus 1 and 2 minus 3. So the value of B will be 4 minus 2 is 2, 2 plus 1 is 3, whereas 2 minus 1 is 1 so that means B value will be minus 3. On the other hand, if you note, when x is equal to 3, so that means if we write down in the substitute in the brackets of A, it will be cancelled. We substitute in the bracket of B, it will be cancelled. You will be left with C only. So that means 3 whole square minus 3 plus 1, and that can be written as C, 3 minus 1 and 3 minus 2. So the value of C is 7 upon 2. So when we write down in the bracket manner, this can be written as x square minus x plus 1, and the brackets are x minus 1, the other is x minus 2, and the third one is x minus 3. It can be written as 1 upon 2 x minus 1, whereas minus 3 upon x minus 2, and the last one will be 7 upon 2 x minus 3. So this will be the answer for this example question, that is x square minus x plus 1 upon x minus 1, x minus 2, x minus 3, which means A is 1, B is minus 3, and A is 1 upon 2, B is minus 3, and C is 7 upon 2. Let's just work with case number 2 now. Your case 2. When denominator consists of repeated roots. Now, what does repeated root means? Repeated root means that we have, let's write down an example, that is 2x minus 1 upon x minus 1 whole square. So now we see that we have a square over the bracket. So how do we open this? We open this as one bracket will be opened as your normal root, which means there would be no square on it, whereas the other bracket or the other variable will be written as x minus 1 whole square. Why did we open up these things as two different values? If I just go back to the basics of LCM, that is x minus 1 whole square. So what we used to have is x minus 1 and x minus 1 whole square. These are your basic rules that when we used to take LCM, we used to take factors. So if I take factor of x minus 1, this x minus 1 is cancelled and the square will be cancelled. So that means you will be left with what? X minus 1 only. So if I write down x minus 1 again, this is 1 and obviously this will become 1 because of the cancellation now. So how many brackets do we have? We have two brackets, x minus 1 and x minus 1. So that means this becomes x minus 1 whole square. So that means whenever there is a whole square on any of the bracket, you will open as a bracket without any power and the bracket with square. Now, with the same example, just writing down the example, if the same question would have been 2x minus 1, x minus 1 cube. So it would have been A x minus 1, B x minus 1 whole square plus C x minus 1 cube. So we would have opened till C with the cube. But obviously we'll be doing such question after this example. So now knowing the fact that this particular 2x minus 1 upon x minus 1 whole square will be opened as A upon x minus 1 plus B upon x minus 1 whole square. But remember this, that the LCM for both will still remain same, because obviously, as I said, that for partial fraction, the LCM will be same as x minus 1 whole square. So we write down A. With A, we write down x minus 1 and B will be alone because x minus 1 whole square, x minus 1 whole square is cancelled out. Remember this thing that when you write down the value, your LCM is divided by the denominator. So x minus 1 whole square divided by x minus 1. So x minus 1 in square is cancelled. You are left with only x minus 1. This x minus 1 will be multiplied by what? A. Whereas this x minus 1 whole square is divided by x minus 1. So this entire bracket is cancelled. So you are left with 1. 1 multiplied by b is only b. So similarly, if we just write down or if we just see that this x minus 1 whole square, x minus 1 whole square is cancelled out, you are left with only 2x minus 1 a x minus 1 plus b. Now, remember one thing. As I said, if the roots would have been linear, it would have been linear, we could have equated with the 0. Now, here roots are repeated. So, obviously, you can't equate it with 0. So, what you need to understand is the comparing method. You need to understand is the comparing method. And for comparing method, what I need to do is I need to open the entire equation. I need to open the entire equation, which means 2x minus 1. This will be ax minus a plus b. Ax minus a plus b. And can I see that this particular x here can be compared to ax? And this minus 1 is constant because it does not have any x square, it does not have any x cube or any particular value, it is only constant. So it will be compared to minus a plus b. It will be compared to minus a plus b. So let's just work out through the working for this. Let's do this. 2x is equal to ax. Your x-axis cancelled, so value of a becomes 2. Whereas minus 1 is equal to minus a plus b. Minus 1 is equal to minus 2 plus b. Minus 2 goes on the other side, becomes plus 1, minus 1 plus 2 is equal to b. B becomes what? 1. So your two values are there, a as 2 and b as 1. So when we write down the equation, which is already there in the question as 2x minus 1, x minus 1 whole square, we write down as 2 upon x minus 1 and 1 upon x minus 1 whole square. And this would be the answer for the example question, that is 2x minus 1 upon x minus 1 whole square to solve as partial fraction. And we write down as what? 2 upon x minus 1 and plus 1 upon x minus 1 whole square. Okay, let's do the other example, that is x square minus x plus 2 upon x plus 1 to cube. Now, this bracket will be opened as a upon x plus 1, b upon x plus 2 whole square, and c upon x plus 1. I'll just correct this thing now. This is x plus 1 whole square and x plus 1 cube. Because all the bracket will be same as x plus 1 cube, right? So initially, what we do is x square minus x plus 2. We write down as x plus 1 to cube. Your LCM for the entire question will remain same as x plus 1 cube. So with a, we're going to write x plus 1 whole square because x plus 1 cube divided by x plus 1, obviously we are left with only cube. Whereas with b, we write down x plus 1 only. And with c, nothing will come because x plus 1 cube is divided by x plus 1 cube, it is cancelled out. Similarly, this denominator in this case will be cancelled out as well. So when the denominator in this case will be cancelled out, you will be left with x square minus x plus 2 is equal to a x plus 1 whole square plus b x plus 1 plus c. Remember that obviously whenever you do not have linear roots, you have repeated roots or obviously improper roots, that is in case 3, we will be using your comparing method. So just open the brackets, x square minus x plus 2. This will be open as x square plus 2x plus 1 plus bx plus b plus c. Furthermore, we open it as ax square plus 2ax plus a plus bx plus b plus c. Now, we can see that your x square can be compared to ax square. Your minus x can be compared to plus 2ax plus b, because I see x, x, and x. Whereas this constant number can be compared to a, b, and c. So let's just start working over to find the values. So we know that we have x square as ax square. X square is cancelled, so a value becomes 1. You know that we have minus x is equal to, we write down as 2ax plus bx. So this would be cancelled as minus 1 is equal to 2a plus b. Minus 1 is equal to a value is 1 from this part. This should be minus 1 minus 2 is equal to b. B becomes what? Minus 3. And finally, what do we have? We have 2 can be compared to a plus b plus c. So 2 is 1 minus 3 plus c. 2 is equal to 1 minus 3 becomes minus 2 plus c minus 2 plus c. So 2 plus 2 is equal to c. C becomes what? 4. So if we just write down the answer in the correct manner, this should be x square minus x plus 2 upon x plus 1 whole square, which can be written as a value is 1, 1 upon x plus 1, minus 3 upon x plus 1 whole square, this is cube, and lastly we have 4 upon x plus 1 cube. So the question was x plus 1 cube. So this will be the answer for x square minus x plus 2 upon x plus 1 cube. So we have x square minus 3 upon x minus 1 and x plus 2 whole square. So in this question, if you see, what we have is, this is your linear root and this becomes your repeated root. So one equation is linear, the other one is repeated. This will be open as a, whereas this will be open as b upon x plus 2 and c upon x plus 2 whole square. So if we just write it down in this form, that a upon x minus 1, b upon x plus 2, and c upon x plus 2 whole square. So can we just write down this thing as your LCM, that is x minus 3. Your LCM will be same as that is in the question. So that would be x minus 1 and x plus 2 whole square. Your LCM will remain same for the entire question, which will be x minus 1, x plus 2 whole square. Writing down the values, if we see that your LCM x minus 1, x plus 2 whole square divided by x minus 1, you will be left with what? X plus 2 whole square. Remember that with b, you have x minus 1, x plus 2 whole square. Can we say that x plus 2 can be cancelled out, which means this can be written as x minus 1 and x plus 2. Similarly, for c, what we can have is x minus 1. We are going to cancel out these two denominators. So what do we have? We are left with x square minus 3 is equal to a x plus 2 whole square plus b x minus 1 x plus 2 plus c x minus 1. Remember, as I said, we only had one linear root. We only had what? One linear root. So since we have one linear root, x minus 1 is equal to what? 0. So since x minus 1 is equal to 0, we can write down as what? 1. So since we have x is equal to 1, when x is equal to 1, let's just substitute 1 square minus 3a 1 plus 2 whole square. Can we write down 1 in this? Substitute 1 in x. So if we substitute 1 in this x, this will turn out to be what? 0. When this turns out to be 0, that particularly means that the entire b bracket should be 0. Similarly, for c, if we write down 1, this entire will become what? 0. So what we're going to do is, we're going to write down as 1 square is 1, minus 3, we'll be left with what? Minus 2. A will be having 3 square. 3 square is what? 9. Minus 2 upon 9 is equal to A. So value of A becomes what? Minus 2 upon 9. Similarly, as I said, we need to have what? Since we have repeated roots, for repeated roots, you will be using the comparing method. For repeated roots, you will be using comparing method. And your comparing method starts right from the question itself. That is x square minus 3a will open the bracket as what? X square plus 4x plus 4 plus b. This bracket will be opened as x into x is x square plus 2x we have is minus x minus 2 plus what? Cx minus c. And we need to further open it as x square minus 3. This will be ax square plus 4ax plus 4a plus bx square. 2x minus b is what? X. So this should be what? Plus bx minus 2b plus cx minus c. So now we'll be comparing the methods. That will be x square will be compared to what? Ax square and bx square only. So since it will be compared to the values, we can always write it as x square is equal to ax square plus bx square. Considering this, we know that x square will be 1. This can be written as a plus b. Now, with the value that you already found out for a, through what? Linear root, we can substitute the value that is minus 2 upon 9 plus b. So b becomes what? 1 plus 2 upon 9. Taking down the LCM, 9 plus 2 is 11. So b becomes what? 11 upon 9. Similarly, since we have b, we also need to find c. We can compare c with x. If I compare c with x, your x, we do not have any value that represents x here. So what do we take? 0x. We'll be taking 0x. Similarly, we'll be taking 4ax, bx, and cx to be compared with. So let's just write down 0x is equal to 4ax plus bx plus cx. Can we say that all the x here can be cancelled out? You will be left with 0 is equal to 4a plus b plus c. A value still remains what? Minus 2 upon 9. B value remains what? 11 upon 9. Since you need to find out value of c, your c is minus 3 upon 9, which can be written as what? 1 upon 3. So finally, what we can have is, we can write down the answer for the form that is given initially. That was x square. That was x square minus 3 upon x minus 1, x plus 2 whole square. Your a was minus 2 upon 9, x minus 1. Your b was 11 upon 9, which is x plus 2. And finally, your c was minus 1 upon 3, which can be written as what? Minus 3 upon 9, which can be written as minus 1 upon 3, which is x plus 2 whole square. So this will be the answer for the question x square minus 3 upon x minus 1, x plus 2 whole square.